Alright, good morning students. You're on to Mamo with Jarvis, and today we'll be looking at grade 8 algebra. Funny enough, I'm having grade 10, that's wrong. That ought to be grade 8. So that's grade 8 algebra. I will continue with our discussion on linear equations using balancing method. Balancing method is a very interesting method for solving linear equation. It is one method that helps you to be disciplined in solving problems. Our textbook of reference will be the New General Mathematics for JSS2 grade 8, and we will go right away to exercise 13C on page 102 of that textbook. We're going to try to see what happens when you solve linear equations using balancing technique, where you have the equations having what? Brackets. So let's watch and see what we ought to do. For instance, question 1. In question 1, we have 2 into x plus 5 equal to 18. 2 into x plus 5 equal to 18. Now the big question here will be, what would you do here? Our technique, our approach to solving mathematics involves you using every aspect of your brain. That's our approach in MAMU. If you look at this very well, what's outside this bracket is 2. What is here is 18. There is a connection. They are both what? Even numbers. So the best thing to do here is to do what? To divide both sides by 2. I hear a number of students will say, okay, traditionally you open the bracket. It's not always the case. You only open the brackets when you have exhausted or you've tested that these numbers cannot be divided by a factor. Hence, we studied factorization much earlier. So we go ahead, we divide both sides by 2, change of marker just to create emphasis, and you're going to have x plus 5 being equal to what? 9. At this point, we will now go back to apply the principles we've learned earlier, and that will be what? X plus 5, removing 5 from both sides. We don't need 5 on the left hand side because we have said that the left hand side can only take unknown or letters, and the right hand side can only take what? Numbers. So with that said, x will be equal to what? 4. And that clears out question number 1. Now we look at question 2. In question 2 we have 15 equal to 3 into x minus 3. Like I said, our approach in solving mathematical problems is to engage our imagination. There is no particular way to say this is how you must follow the time, because sometimes in an exam setting your decision is based on what you remember. What you do is a function of what you remember. So I'll try to take my own narrative in handling this and then leave you to make your own decision while solving. We remember that from board maths we are expected to deal with the brackets. So if we bring that idea to bear here, it will be better for me to identify what can divide both sides first before I do any other thing. So this will be my own approach to solving the problem. I'll divide both sides by 3, which I have identified to be a factor that can divide both. And that will give me 5 equal to what? X minus 3. At this point, I will do what? I will rewrite, because the coefficient of x here is what? Positive. So this will be x minus 3 equal to 5. At this point, I do not need negative 3 on the what? I don't need negative 3 on the left hand side, so I'll have x minus 3 and I'll add 3 to both sides to be able to clear that one out, and that will be x equal to what? 8. So you discover that in this exercise, we just want to show you how to handle brackets, and at the end of the day, what you discover is that all these processes are things you've already been taught. So I always advise my students, when solving problems in maths, Especially when you have examples or you have exercises, don't jump a question. Take from 1 to 2 to 3, because for every question there is an idea that you expected to grab. Alright, so we go to the next question, question 5, and that will be 4 into x plus 7 plus 12 equal to 0. If you watch carefully, you discover that there's an even number here, there's an even number here. Please resist the temptation to do what? Open the bracket. It's not a wise decision to make. So what I will do, I will suggest here is this. This one that's in the bracket here, treat as 1 term, and then look for a way to move this 12 to the other side. So you subtract 12 from both sides to clear this one off. And that will be 4 into x plus 7 equal to negative 12. At this point, you can now divide both sides by 4. And this will give you what? X plus 7 equal to negative 3. So what you do at this point, this will be x plus 7. You subtract 7 from both sides. And that will be x equal to negative 10. That will be the answer to the question. Okay, in question 7, we have 6 into 2s minus 7 equal to 5s. If we look at both sides of the equation, you discover that nothing can exactly cancel out. There's no factor common to the coefficient of this and to the number multiplying this bracket. It is in this kind of condition that we expect you to open the brackets. So you don't just open brackets. There are laid down conditions to open a bracket, especially when it pertains to equations. For an equation, we expect you to open brackets only when you don't have factors or coefficients that can cancel both sides. So with this, we will try to open this bracket, and this will give us 12s minus 42 equal to what? 5s. At this point, you would observe that we don't need 42 on this side, and we compare 12s and 5s, which is bigger. 12s is obviously bigger and better than what? 5s. So what do? We will then think of a way to eliminate this, and that will be by adding negative 5s to both sides. Please, whenever you're doing this, do it gradually. Don't be in a hurry. It's a stepwise something. You do it gradually. So with that, you're going to have 12s minus 7s, giving you 12s minus 5s rather, giving you 7s minus 42 equal to 0. So that will mean that 7s minus 42 plus 42 to both sides will be equal to 0 plus what? 42. So what happens at the end of the day? 7s will be equal to what? 42. What do you do at this point? You divide both sides by 7, and that will give you that will mean that s will be equal to what? 6, and that clearly handles that problem. Okay, we go to the next question, and we have a bracket. We have two brackets, one on the left hand side, one on the right hand side. You observe that the numbers multiplying the brackets don't have factors that are common. So it is on this kind of setup that you do what to open up the bracket. So this 7 will multiply this. This is number times number letter. The answer becomes what? 14e. Number multiply number plus 7 multiply this to give me 21 equal to 3 multiply number letter. The number multiply number plus 3 multiply this to give me 27. At this point, we will now do some rearrangements. To rearrange, we must keep in mind that the letter is kept on the left hand side and the number is kept on the right hand side. So if you compare the letters, you discover that this is bigger than this. So for this reason, we will retain this and remove 12e from both sides. That will be what? 2e plus 21 equal to what? 27. What is next? We don't need 21 on the left hand side, so we'll remove that. That will be 2e plus 21 minus 21 equal to 27 minus 21. And that will be 2e equal to 6. I divide both sides by 2, and e will be equal to 3. E becomes what? Equal to 3. So e will be equal to 3. So in question 17, we have that. Now, when you have a question like this, I would advise you, open the brackets. What do? Open the brackets. Especially when you have the terms on one side. Open the brackets. So you open the bracket, you're going to get 2y minus 4 plus 3y minus 21 equal to 0. What do you do next? Collect like terms. That should be the next thing you do. But with my modern approach to mathematics, I've also tried to introduce what is called randomness. Because I discovered that a lot of our mathematical processes are too mechanical, and some students find it difficult to cope with this overly serious, and so you can. Depends on your level of knowledge. If you look at this carefully, now look at this. These two terms are alike. So I'm going to have what? 5y. 2y plus what? 3y. Now these two terms are alike also. Negative 4 minus 21. It means you're owing 4 naira and you're also owing 21 naira. What would that be? That would be addition. Now, you are doing addition when the signs are the same, and doing subtraction when the signs are different. If you look at this number, the sign here, though negative, and the sign here, though negative. When you're working with them, you're going to do what? Add them together. So that will become what? Negative what? 25 equal to 0. Now, there's a technique I didn't introduce earlier. I'm going to drop it here now so that you can see how that works out. If you look at 5y and 25, there's something common to both, and that is what? 5. So I will apply my knowledge of factorization. I will factor 5 out. That will give me 5 into y minus what? If I factor 5 from 25, I will get what? 5 equal to 0. At this point, I will divide both sides by 5. Take note of something, a very interesting observation here. 0 over anything is equal to 0. Where A is anything, anything at all. Number, letter, you, me, Mamu, Jarvis, Wheat. You're going to get 0 over A being equal to 0. Note that knowledge. It's so important you don't forget it. So with that said, it means that y minus 5 will be equal to 0. So what we do at this point? We don't need 5 on the left hand side. So we do what? We add 5 to both sides. This will now be y minus 5 plus 5 equal to what? 0 plus 5. And that will mean that y will be equal to what? 5. So the final answer is now what? Y equal to 5. Alright. Now, this problem is not different from this. But the real difference here will be having a negative here. No factor present here. So what we need to do is to open up the bracket. So understand when you open up brackets. Brackets are opened on the grounds that there are no factors. So this will be what? 3 or 3 times 2x will now be what? Number, letter. I say that number, letter. That will be what? 6x plus number, 9. Now, this is a negative. This negative is going to change in content. So this is positive, this is positive. So in writing your answer out, both must be what? Negative. So negative times letter will give you negative 7x. Negative times number will give you negative 14 equal to 0. So what do you do at this point? You collect like terms. But still treating the concept of randomness, I will collect them randomly. Look at this. This is positive and this is negative. What that means is that I'm going to get a negative. Why? This 6 is smaller than this 7. But 7 is carrying negative. So my answer will be what? Negative x. I've seen students having this habit of putting negative 1x. There is nothing like this. Because we have a fundamental idea that says that 1 times anything is that thing. So why you say 1 apple as just any other person, as a mathematician you simply say what? Apple. So 1 apple mathematically is said to be what? Apple. Is that clear? So with that idea it becomes negative x, and then we look at this 9 minus 14. This 14 is bigger than 9, but the negative is on what? 14. So you put a negative here and you now say 14 minus 9, which will be what? 5, equal to what? 0. At this point, we have to, because this is carrying a negative, we need to do what? Rewrite. So this will be 0 equal to what? Negative x minus what? 5. Right? So we can then go ahead to say that 0 plus x, which is what we need on this side, will be equal to negative x plus x minus 5, and x will be equal to what? Negative 5. That solves that question. So with that, we have been able to exhaust possible questions or scenarios we can see when we talk about equations with what? Brackets. Next, we're going to look at how we handle fractional problems, or what we may call algebraic fractions in equations. You're laughing. Alright. Okay, let's look at equations with fractions. Now, how do we handle equations with fractions? The first thing we must remember is to look at their denominators. Look at their what? Their denominators. So, if you look at this one, now, this is a very simple arrangement of it. Look at this denominator, it is what? 3. So, what you do now is to multiply both sides by the denominator of one of them. So with that, this will now cancel out, and my answer becomes what? 15. So if this were to be 5, I multiply both sides by what? 5. But because this is 3, I multiply both sides by what? 3. Are you seeing that? This is about the easiest question you can see in this arrangement. Alright. Now, it has become a standard practice for students to ask, can I cross multiply? The first thing I will tell you is this: I am not aware of anything called cross multiplication. If there exists anything like cross multiplication, it may be in matrix, and we call that the cross product. Cross multiplication does not exist in maths. Those who are mathematics scholars stand to correct me on this. What you will do in this setup is to look for the LCM. That's why you were taught LCM. What is the LCM of 5 and 2? That will be 10. In case you've forgotten how that is done, we go to our elementary approach. So the LCM is what? 10. It is this term by balancing technique that you can use to multiply both sides. Or both sides rather. So I'm going to have x equal x over 5 times sorry. We can use that approach. Okay, let's use that. Let's not bother about that. Something crossed my mind, and equal to what? 1/2 times 10. And that will be what? 2x equal to what? 5. And then I divide both sides by 2. And I'll get x equal to 5/2. Now, I always advise students, when you solve, really don't bother so much about trying to write this in mixed numbers. That's not really our concern. Our concern is best for you to keep them as what? Fractions, either improper or proper, as the case may apply. So this is just one way to solve this. Now, I'm going to use another approach to solve this now. Okay, as a little modification to this method, generally, I just said that we multiply with the LCM. Now, that applies in some questions. For this one, if I'm going to multiply through by the LCM, I'll be giving myself extra work or giving myself an unnecessary step. So what do I do? What do I do? I identify the denominator of the unknown. I identify what? The denominator of the unknown. So that will be 5. I will then multiply both sides by 5. And that will be x equal to 5/2. So you discover that with this technique, I have saved myself one unnecessary step here. Do you get it? Have I said that what I've done here is wrong? No, it's not wrong. But I've given myself one unnecessary step. There are problems where this will come in handy, but not here. So for this kind of question, identify what the denominator is and use that to multiply both sides. Alright. Okay, so we yet have another question on the board. We have 4 equal to a/9. Now, there are 2 ways you can go about this question, and they will both give you the same desired effect. But if you look at this arrangement, I want to take care of the denominator first. It's a decision I've made to take care of the denominator first. So what do I do? The denominator here is 9, so I multiply both sides by what? 9. So this will be 4 times 9 equal to a/9 times what? 9. So what do you have? You have that a will be equal to what? 36. At this point, we do not expect our a to be on the right hand side, but we need it on the left hand side. So we do what? We rewrite. So a will be equal to what? 36. This is where we're going to stop in our understanding of mathematics this morning. We will continue with this topic in another video production. Equations with fractions. It's a very broad area. So fractions are the area of algebra that usually gives students a bit of an issue. We'll continue with this, and then for now, I want you to go back, watch and re-watch. It takes interest and practice. And the only way you show your interest and you put yourself in a position to practice is to re-watch. Re-watch till understanding comes. So Mamu with Jarvis signing out for this morning. Thank you very much for your time, and God bless.